Alright, because it's asking you to find the x-intercepts, first, what I would do is solve this equation, make it equal 0, and find all the values of the x-intercepts for the required domain. Okay, now before I do that, you can get a quick idea about what it looks like by looking at the transformations. Let me put that up. So with the transformations, I don't want to do that on this paper. So what you need to do is quickly, you need to know what sine of x look like. So over the two interval, so it's going to look like that. So again, you need to be really fluent with how to draw your sine of x. Know your exact value in the first quadrant and find your maximum and minimum. So that's pi on 2 and that's 3 pi on 2. Okay, now if I look at that function that had originally the root 2 tells you it's the magnitude, so that's going to be root 2 negative root 2, but because you have a plus 1 which is vertical, what it'll tell you is you will have the maximum will be root 2 plus 1, and then the minimum will be 1 minus root 2. Now before I move on, notice there's no n here, so the period is still 2 pi. So if I plot just y equals root 2 sine of x plus 1, the way you could graph this is by changing your plus 1. So my x axis will shift somewhere here, because what we do is if I shift the x-axis 1 unit down, what happens is the function is moving 1 unit up. Okay, now that won't change those midpoints here, those intercepts, because they're not affected by the amplitude. What's going to change when you multiply by root 2 is that maximum is going to stretch upwards and this one's going to stretch downwards. Okay, so that's just for sine of x times root 2 plus 1. Now let's do moving on to the next one, which is sine of x minus pi on 4. So remember, you can do the mapping, but what you've learned in the past is when you do minus pi on 4, it's a translation of pi on 4 units to the right. Okay, and what you do is, if you go back to your curve and you look at your original intercepts, they're going to move pi 4 to the right. So that's your pi on 2. Pi on 4 is half. And all you need to do is shift this to the right, that to the right, and you do the same with the maximum. Hang on, what's that value here? That's right. Oh, that's 3 pi on 2, so that's going to shift over here. Okay, now as you shift it to the right, you're going to, that point, somewhere this point here is going to shift over here. Okay, now what you're missing on that side that you shift, you're going to copy it from the end point, the end part next to the 2 pi. Okay, because 2 pi is a period, so you can always sorry, anything on the right hand side of 2 pi, you just copy it over here back to the beginning. Okay, so by doing this, it gives you an idea. Now let's go back to this. So the way you started, you said you make it equal 0. We're looking for the new x-intercepts. Yeah, you can see Okay, so we make sine of x minus pound for the subject. That's negative 1 over root 2, which is negative 1 over root 2. It's sine of would that be negative pound 4? Okay, so you need to know your exact values and bring it back to the first quadrant. So that negative means it's in the fourth quadrant. Or you have negative sine of pound 4, you can bring the negative sign inside, because we want both sides to be assigned to find one value, and we're going to call it the value in the first quadrant. Okay, so what it means is, for sine, the general solution, you have a solution in the first and the second quadrant. In the first quadrant, it's going to be negative pound 4 plus 2k pi or n pi. And the one in the second quadrant, it's going to be pi minus theta. So that's pi minus theta is the one that I have the first value I found out. Okay, this one, let me do that. So that's sine, that's actually x minus pound 4. Okay, now we transpose the minus pound 4 on the right hand side. So x is equal to, for the first line, it's pound 4 minus pound 4, so that's 0. How am I getting the same? Oh yeah, that's fine. Yes. You just instantly, by substituting 0, that's fine. Yeah, because it has a root 2 and a 1 when you do, yeah, that's fine. So that's 0 plus 2k pi. And the second one is pi plus pound 4 plus pound 4. So that's going to be, shouldn't it be, that's really weird. I'm getting weird results here. Hang on, bear with me. So that's Q1. That's Q2. Why do I get 3 pound 2? I'm just looking at this one again. Oh yeah, that sounds about right. Okay. Okay, so now over the interval 0 to 2 pi, those are the only two x-intercepts that we have. Okay, so now you can do this. Alright, so we're going to go from 0 to pi. Pi is in the middle, pound 2. Okay, I need pi. Now you need to kind of remember this bit as well here, because I'm looking at the maximum and the minimum. Okay. Alright, so what I need as well, I'm gonna need it's plus 1, so I need 1 as well. So 1, let's say I have 1, 2, 1, 2 in the negative axis. You also need to approximate root 2. Root 2 is 1.4, which is higher than 1. So that's going to be 2, and it probably up to 2.5. Okay, so I have pi on 2, 3 pi on 2. So I can annotate, I have the intercept. Okay, I'm going to draw my line y equals 1 because that's the mid value. That's where you used to have the old x-intercept before you did a vertical translation. So that goes to, I need a pi on 4. Pi on 4 and pi on 4. I need this one. So at pi on 4 is the mid value at between pi and 3 pi on 2, which is that one. Now looking at the maximum was at pi on 2 plus pi on 4 to the right. So pi on 2 here. That's my maximum, so that's going to be 1 plus root 2, which is about, it's 2.4. The minimum is on the pi on 4 plus 3 pi on 2. The minimum is, that's 1, and you minus root 2. Me, I'm going to do is I'm going to measure that, because that's my amplitude, and it's going to be over here. Okay, now I'm going to annotate as well the next. Now it's beyond the domain. Over here you actually have another midpoint here. It's over 2 pi. Okay, and then we have our function. I think I can join now. Alright, so it's going to go like that. So that's the minimum. There was another one. Actually, that's wrong. It's over here. No, wait. Yes, it is. Or not? No, it should be 2 pi. Yeah, it's 2 pi. Sorry, it's here. So that was correct. Okay, oh, so I did forget a point. So when I go back to this one, when I have x equals 0 to k2 pi, so you have 0 and 2 pi, and this one is 3 pi on 2. Those are your intercepts over the domain. Okay, and we annotate the endpoint. Let's say you wanted it will be a larger question with more. Oh, I forgot this one. So it's 3 pi on 2, 0. Let's say you would do a full graph. Don't forget to annotate your minimum, maximum. So to find the y coordinate of maximum, it's root 2 plus 1. This one is going to be 1 minus root 2 for the y coordinate. Now for the x coordinate, is looking back at your maximum. So that was pi on 2, and you translate to the right. So it's pi on 2 plus pi on 4. So that's 3 pi on 4. Okay, and the same here. You have 3 pi on 2 plus pi on 4. So that's 6 on 4. That's 7 pi on 4. Hopefully. Okay. That's just extra for the minimum and maximum. Okay, and then you get your the graph of your function.